On the board, you have CE is the diameter of a circle A, B, C, D, and E. If angle ABC is equal to 127 degrees, find ACE. On the board, you have a circle geometry in which the angle B is given. You have your ABC, angle B given. In all, you have A, B, C, D, and E. And you are being asked to look for A, C, E. If you look at this circle, you have two different shapes. You have a quadrilateral and you have a right angle triangle. You have a quadrilateral being inscribed in this circle, and you have a right angle triangle which is angled in a semicircle, 90 degrees. Now, before we can be able to get our ACE, first of all, we need to solve for EDA, because the EDA will give us our ACE, which is angle in the same segment are equal. I repeat, in order to get our ACE, we need to solve for EDA, so that the EDA will give us angle in the same segment. EDA, angle in the same segment. Now, how do we solve? First of all, let's solve for ADC. Our ADC. If you watch, we have two angles there. We have the quadrilateral and we have the right angle triangle in this same place. Now, first of all, let's solve for ADC first. ADC. If you watch, our ADC is opposite to 127. Our ADC is opposite to 127, which means the opposite cyclic quadrilateral is supplementary. So it will be our ADC, angle ADC is equal to 180 minus 127. Our ADC, it will give us our 180 minus 127. This here is 3, here is 5. So we have our 53 degree. 53 degree. So what will you put? Opposite cyclic quad is supplementary. This is supplementary to this. It means that here and here is 180. Here is 90. Here is 90. When it's being added together, gives 180. Now, if here and here gives us 180, now we are looking for this other side. To get this other side, you say 180 minus the 127, which will give us 53 degree. And this 53 degree, you put to the opposite cyclic quadrilateral as supplementary angle. Now we've gotten our ADC. Now, since we've gotten the ADC, now we need to search for EDC. And if you watch on the board, your EDC is angle in a semicircle. Angle in a semicircle. And the angle in a semicircle is equal to 90 degrees. Whenever you have an angle in a semicircle, it's 90 degrees because of this dot you're seeing here. And it's opposite to this angle, making here 90 degrees, angle in a semicircle. So we have our EDC, which is 90 degrees. What will you put? Angle in a semicircle. So having gotten this, if you watch, we've gotten the two angles here now. First of all, we search for ADC, and the second we solve for EDC. So here we have two angles embedded here. We have two angles. We have angle 53 degree here. I also have angle 90 degree. This same place. Now we want to work with one angle, not two. We want to work with one angle. Now, how do we get the main angle in which we work for? First of all, very simple. We need to subtract this 53 degree from 90 degree to get one angle we used to work with. Now, when we're able to get that angle, we'll call it our ACE, which is angle in the same segment. Because if you watch this now, this looks like a butterfly. If I'm to redraw this, it looks like this. It looks like this. You see it now? If you watch inside, it looks like this. And they say we should look for this side. In order to get this side, you need to get here first. So when you get here, anything you get here, you call it the same thing here, making it angle in the same segment. So that is why we need first to look for this side, which is this angle here. So when we get here now, we'll call it this other part, which is angle in the same segment. That is the meaning of the ACE we are talking about. Now, we need to know one of the angles here, because in this angle now, we are having two angles here. We have angle 53 degree here, and we have our angle 90 degrees still here. We want to make use of one angle. Now, how do we make use of one angle? How do we get the one angle? Very simple. How do we do that? We call it, we say EDA will be EDA now will be 90 degree minus 53 degree. Remember, I told you are looking for one angle. So now to look for one angle, you're going to do 90 minus 53. Here is 8, here is 1, 7, here is 3. Here will be 37 degree. So that means you are making use of 37 degree now. Because since we have two angles here, we subtracted each other, we got 37 degree. So that means our EDA is 37. Remember, there was a drawing I drew before. So that means if I'm to redraw this now, looking like this, if I'm to redraw this like this, that means this part now is 37 degree. So if here is 37 degree, this same part will also be 37 degree, which is our ACE. So here it is 37 degree. Why is it 37 degree? Here is 37 degree and this is 37 degree because they are on the same segment. Angle in the same segment are equal. Or we know that in angle in the same segment, when you have two angles facing the same part, both angles will be the same. Why? Because they are angle in the same segment. If the angles are here, for example, here is 37, here will be 37 because they're in the same segment. They should be equal. If you're 37, you'll be 37. Why? Because they're in the same segment and they should be equal. So, since we've gotten our 37, since here now, our EDA is 37 degree, here will equally be 37 degree. Why? Because the angle are in the same segment. So, we said our EDA is 37. Therefore, if our EDA is 37, then our ACE also give us 37 degree. Why? Angle in same segments. So that means our ACE will be 37 degree. Why? Because it's in the same segment as this. Look at it. In the same segment as EDA, the same segment. Very simple. Thank you.